Good morning, everybody. We're going to do the digestive system intro notes, and most of the notes for this unit will be on the big sheet. So we'll go back and forth between the front and back of this big sheet, and then tooth structure for a little bit, but we're not going to do the whole thing today. I think it's a lot to cover the whole entire big sheet with all of the boxes. So if there's not a lot of information in the box, then we'll go ahead and do it. But if there is, we will wait until tomorrow because tomorrow's notes are not as long. So here we go. We're just going to go over digestive system anatomy today and some of the structures, the big structures in the digestive system, and then we'll split them up into their parts and more information about them a little bit later. All right, so first thing in the digestive system is the oral cavity, and this is just your mouth, okay, the space where your food would be found, the space where saliva is, and so it is a cavity. Remember, a cavity is a space or a hole. Inside that cavity is going to be your tongue, and it looks kind of odd on this picture, but remember that this is just a cross section or a side view of the tongue. It is muscular, and under the tongue you have some different salivary glands. One is called a sublingual gland. That literally translates to under the tongue. And then under your jawbone, you have a submandibular gland. Remember, the mandible is your lower jaw, your lower jawbone, and that submandibular gland is going to be situated under there. The big salivary gland is going to be the parotid salivary gland, and it's up in your cheek. If you have mumps, the parotid salivary gland will swell. It'll make you look like really, really big chipmunk cheeks. If you ever eaten a lot of sour candy, or eaten like a warhead or something, and that it feels like your cheek is pinching, that's just the salivary gland, or the parotid salivary gland specifically, trying to release a lot of saliva to counteract that acidity of the sour taste. Also in the oral cavity, we have teeth. That would obviously make sense. Those teeth are there to shear or grind or cut the food to mechanically digest it, meaning to make it into smaller pieces. And we'll go over the different types of teeth in just a couple of days. All right, when you go to swallow, you've got two options. You've got air that needs to go down your trachea. You've got food that needs to go down your esophagus. The flap that's going to cover your trachea, so we're just going to take this piece of tissue, this elastic cartilage, cover up the trachea in the front. And remember that epiglottis, again, is elastic cartilage. Glot means opening. And so the epiglottis is upon the opening of your trachea. Before you get to the epiglottis, there's just this common area in the back of your throat where air and food mix, and that's called your pharynx. Pharynx means throat, and we're not going to pronounce it pharynx, even though it has a Y, it's not pronounced like an I. And then the food would travel on down into the esophagus, which is a muscular tube that runs from your pharynx all the way down into your stomach. So we'll do a few of these functions now because they're not as involved as some of the others. So the boxes are going to cover just the overall function of that area of the digestive system. The first one is the mouth or oral cavity. The purpose of the mouth is mechanical digestion. And in the mouth, food is called a bolus. Okay, a bolus is just a ball of food that is mixed with saliva. And the name for food is going to change as we move through the digestive system. And I'll try to be careful to call it food and not call, or I'll try to be careful and call it the correct term instead of calling it food the entire time. So a bolus, again, is what it's called in the mouth and also in the esophagus. Inside the mouth, we're going to mix with saliva, and that saliva is there to moisten, lubricate, and bind food together. It's necessary. Okay, you need that saliva to help mix the food, but it also has salivary amylase in it. Remember the stem ASE is going to indicate an enzyme, and salivary amylase will break down big sugars into smaller sugars. So the big sugars are called polysaccharides, and they will get broken down into disaccharides by this salivary amylase. If you've ever thought about eating a peppermint or eating any kind of mint, really, it'll just kind of disappear in your mouth or disintegrate. And that's because it's nothing but sugar. And so that sugar is going to be broken down by salivary amylase and will cause the polysaccharides in that mint to be broken down into disaccharides. There's also going to be other amylases throughout this process. Some are like pancreatic amylase. So it is important to put salivary amylase and not just amylase because they're found in different areas of the digestive system. Alright, on this page, we're just going to fill in the esophagus box first since we've already covered that one. This is just a little bit further down. The esophagus, purpose of it is just to squeeze food from your pharynx all the way down into your stomach. That squeezing or wave-like propulsion of food is called peristalsis. Okay, so there's an L there, peristalsis. And that's done by the musculature inside the esophagus. Some are striated obliquely, some are striated in an orbit shape, some are striated longitudinally. And so the combination of those muscles contracting based on their different striations is going to squeeze that food down into the stomach. Okay, now we'll just call it the stomach right now. Tomorrow we'll split it up into more parts, but the stomach is shaped like a letter J, and it's as big around as about your thumb to your pinky. So if you stretch your hand out like you're saying, spurs up, go Cox, with your thumb and pinky stretched out, that's about how big your stomach is when it's not full, and it can get as big around as much bigger. I don't know the exact size, so I don't want to say, but it can get much bigger and stretch as the stomach is filled with food. And we'll do again a little bit more with the stomach tomorrow. Now, one thing that's a little bit tricky about this diagram is the liver has been pulled up and out of the way. If you think back to the model in class that sits up on my bookshelf, the liver's not just hanging out here in this space. It's going to be tucked on top of the stomach and really cover a broad section of your abdomen. So don't get confused that this liver is kind of out here by itself. It really would sit on top of the stomach in your body. And the liver has different parts. There's a left lobe and a right lobe. Remember, we're doing this from patient's perspective. And because that liver is so massive, it has a ligament that helps hold it in place and hold it to the underside of your abdominal muscles. And the name for that ligament is the falciform ligament. Hopefully we'll get to dissect our pigs, and when you open the pig up, you're like, goodness, there's liver here, and oh, there's more liver, and oh, there's still more liver, and it just keeps going and going, and then there's this obvious falciform ligament that you have to snip in order to get the liver out of the abdominal cavity. All right, the purpose of this liver is to really make bile, okay, and bile is green, is sticky, and its job is to emulsify or mix fats. And that bile is going to get stored in your gallbladder. Okay, so number 12, there we go, is your gallbladder. Now, the gallbladder does not make bile, it just stores it. The liver's job is to make it, and in order to get it into the gallbladder, it's going to travel down this hepatic duct. Okay, so the hepatic duct is right here. It is draining the bile from the liver. And then in order to get it over here into the gallbladder, you're going to travel through the cystic duct. So when that bile leaves the gallbladder as well, it's going to leave the gallbladder and go down the cystic duct, continue down, continue down, continue down, something called the common bile duct. And if you follow my mouse here, that common bile duct is going to empty into the first part of the small intestine called the duodenum. Okay, now there's a lot of different pronunciations of this. I learned it as duodenum, but some professors in college do call it duodenum. I think they're both widely accepted. All right, so the common bile duct again travels down into the small intestine and dumps it into the first part called the duodenum. At the same time, the pancreas is over here making all kinds of hormones and insulin and glucose. I mean, just doing all kinds of stuff for your body. So it's going to release its contents down a common duct, or a duct. Let's not call it a common duct. A duct that runs down the center, and that duct is called the pancreatic duct. And a duct is just a tube, okay, an emptying tube for these different organs. Liver is going to empty its bile through the hepatic duct. HEP, hep means liver. Gallbladder is going to store the bile, and then it's going to get released to the cystic duct. Where those two ducts come together is called the common bile duct. That common bile duct is going to join in with the pancreatic duct and release everything into the duodenum. Again, that duodenum is the first 6 to 9 inches of your small intestine. Extremely important area of your small intestine. All right, we're going to skip over the stomach box, the liver box, pancreas box, and small intestine box for today. We're going to continue down the structures, and then I will do those boxes tomorrow. All right, so 14 is a repeat. Duodenum. That's still part of the small intestine, and again, everything's been kind of scooted up in this diagram. Then it's going to continue through the rest of the small intestine. The second region of your small intestine is called your jejunum, okay, or jejunum. Again, the pronunciations are different. I say jejunum, but again, this is the southern version of anatomy. So the jejunum is the second region of the small intestine. The third region is going to be your ileum, spelled I-L-E-U-M, not I-L-I-U-M. I is the bone, E is the small intestine. The ileum, the jejunum, and the duodenum are all parts of the small intestine. This is where most of your nutrient absorption is going to happen in your body. Therefore, that's why it's as long as it is. It's roughly 4 to 5 times as tall as you. Okay, all packed into one small area in the center of your abdomen. Once you go through the ileum, you're going to go right into the first part of the large intestine. And that first part is called the cecum. Okay, the cecum is like a foyer. Most of the time I describe it as the opening of Sea-Wing. You walk in the door and it's this big area, this big lobby of Sea-Wing. That's kind of how the cecum is. It's the lobby of the large intestine, and hanging off of that is a pinky-sized organ called the appendix. And most people accept that it is a vestigial organ, meaning that it does not have any function. And in my mind, it only causes problems in someone's body because bacteria can harbor down in the bottom of it, start to grow, cause a bunch of inflammation, and then you can end up with an appendicitis. To know where your appendix is, you find your belly button and you find your iliac crest, and it's somewhere in between. So if you draw a diagonal line from your belly button down to your iliac crest, somewhere in the middle of that is about where your appendix is situated. So if you have pain in that area, sharp pain, it's hard for you to stand up, somebody palpitates or pushes on that area, and you rebound, meaning you about come off the table, then you potentially have an appendicitis. If you have a fever, if it spikes pretty quickly, that's another sign of appendicitis. Thankfully, it's a quick surgery called an appendectomy. They can go in there laparoscopically most times, nip it out, and you're good to go. You're back to school within a couple days. All right, so from that cecum, the fecal matter is now going to travel through the large intestine, and it has quite the order that it's going to go through. So from the cecum, the feces is going to travel up, okay? And the name for that part of your large intestine is the ascending colon. Okay, colon and large intestine are the same thing. Large intestine just means that it's larger around than the small intestine. Colon is just really the name for the organ. Small intestine is called small intestine because it's smaller around in diameter, not that it's smaller in length. It's much, much longer in length. Your large intestine is only about, or is about 1 time as tall as you. So it's as tall as you are. Okay, so we go up the ascending colon. Then we're going to take a little curve. Okay, this curvature is called your splenic, not your splenic, your hepatic flexure, because in your body, when the liver is moved down in its correct position on this diagram, it would sit kind of right at the top of this hepatic flexure. And if hep means liver, that's why this is called your hepatic flexure. Then feces will travel across your belly, okay, and kind of across your abdomen, and that's called your transverse colon because we're going across. We take our next little curve, and this is called your splenic flexure, as your spleen sits right next door to this splenic flexure. Then down the descending colon. And about this point, we're starting to get a little signal that, ooh, I think I might need to go to the bathroom kind of soon. Not urgent, but I kind of feel something moving around. And so as you get towards the end of this descending colon, you can start to get those urges to go to the bathroom. Then we take our last curve, and this curve is a pretty sharp one, and it is called the sigmoid colon. Sigmoid means that it has an S shape, and so this has a slightly S shape to it. And at this point, you would have that sensation that you need to go to the restroom. And then from the sigmoid colon, the feces, would get stored in the rectum until you expel it from the body. And the opening for defecation or for going to the restroom is the anus. Okay, the purpose of this large intestine is to store the food, okay, store the chyme is what it's going to be called as it leaves the small intestine, and really turn the chyme into feces. There is no nutrient absorption in the large intestine. The only thing the large intestine is going to do is dehydrate. Okay, take that watery chyme, kind of a pasty, soup-like consistency that is coming out of the small intestine, and dehydrate it and make it into solid feces. The next thing that's going to happen is you get the absorption of some vitamins in your large intestine. Not a lot, but there will be a little bit of vitamin absorption there too. It's not nutrient absorption, so I'm not absorbing carbs or carbohydrates. I'm not absorbing fats. I'm not absorbing proteins. All of that's done in the small intestine and up, but for the most part, everything's done in the small intestine. The purpose of that large intestine, again, is to just make that chyme into a solid waste product. The purpose of the rectum is to store feces, okay, feces is poop, and then to start the process of defecation, which is to poop. And then the anus is just the opening for fecal elimination. There's 2 sphincters to the anus. And when you have that urge to go to the bathroom, or you squeeze those not the rectal muscles, when you squeeze the abdominal muscles and go to the bathroom, the anus is just going to open up and allow that to happen. All right, so let's see how long this is. I'm going to transfer it over, and if I don't come back, then we'll do the other boxes tomorrow. If it's not super long, then I'll come back and finish recording that. So for homework tonight, I want you to turn in your stems, and you can just hang on to that digestive review sheet. You don't have to turn that in, and I only want the stem sheet for homework tonight. And I'll keep you updated on the rest of the details for April. I've got to go to school here in a little while and finish making some copies, or start making some copies, I should say, for the rest of the month, and we'll take it day by day. But that's day one of digestive system.